Assalamualaikum and hi everyone. Today we will present about pressure monitoring with buzzer alarm. And here I represent our group member. My name is Hairil Asyraaf, and here we have Nur Afiqah, Almuazzim and Ariff Zaqwan. Now I will continue to introduction. Instrumentation and control system is a crucial role in ensuring safe and efficient operation in industrial process in oil and gas industry. One of the most critical thing industry is pressure. This is because pressure that did not monitored can cause damage such as pipe leakage and pipe burst. So from that, we are developing an instrument that can monitoring pressure to improve safety and efficiency. What are we focused in this project is developing Arduino based on pressure monitoring system with buzzer alarm, and also this prototype can simulate a real-world industrial safety system in a simplified way, cost-effective way. Next, on this slide, we are focused on pressure monitoring using Arduino. The system is built using Arduino as the main controller. And why are we using the Arduino? Because it is easy to use, flexible and cost effective. The system also can monitor pressure in real time. This is mean the user can get immediately reading without delay. Next, buzzer alarm for high pressure. If this pressure exceeds a safe limit, the buzzer will be activated. And lastly, low cost and simple design. The design is simple and suitable for beginners or small scale use.
I will present about problem statement. In most small-scale process systems, they do not have proper pressure monitoring in their phases, so this can lead to several unsafe conditions such as overpressure in the pipeline, equipment damage, and also even accident or system failure. So, without an early warning system, the operator may not be able to respond quickly when the abnormal pressure occurs. Therefore, it is important to develop a reliable and low-cost pressure monitoring system to improve safety and increase awareness in the system. I will present about objective. The objective of this project are first to design a pressure monitoring system using Arduino, where Arduino will act as the main controller to process the pressure data from the sensor. Second, to measure and display real-time pressure values so user can continuously monitor the system condition without delay. Third, to activate a buzzer alarm when the pressure exceeds a limit, which serves as an early warning system to alert operator of the unsafe condition. And lastly, to develop a simple and cost-effective safety system which making it suitable for small-scale or low-budget application.
Okay, for the method of the project is designed to monitor pressure in real time using Arduino-based system. The system reads pressure value from a sensor and activate a buzzer alarm when the pressure exceeds a predefined. It means the core of the objective is to ensure safety and precision by providing constant of pressure level with the Arduino-based ecosystem. Then, overall system consists of three main parts. First, the output stage. This feature is our pressure sensor which acts like the eyes of the project to gathering raw physical data. Second, the processing unit. The brain of the operation is the Arduino UNO. It takes the raw data, compare it against our safety limit and decide whether an alert has detected. Lastly, the output stage. For this, we use buzzer and display. The display provides a constant visual readout while the buzzer serves as the critical audio warning in case of an emergency that has been detected. After that, of course, with a great design, we must have a cost estimation. So we have carefully selected components that balance and affordability. As you can see from our budget breakdown, the total estimate cost for one unit is 150. So the pressure sensor is our most significant investment at 90 ringgit. That is our highest priority. Then the Arduino units come at 30 ringgit, providing us a processing platform that the LCD display adds at 20 ringgit to build the ensuring the user interface is clear and readable. So the remaining cost is cover the buzzer for RM5, the breadboard and wire RM50, for the circuit assembly and miscellaneous fund at RM20 to cover any small hardware extra or replacement. Overall, we believe it is a highly cost, but we will make the project successful.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ariff Zaqwan. Today I will talk about extended output. First, real-time pressure reading will be continuously displayed on the LCD screen, allowing user to monitor pressure value at any moment. Second, a functional buzzer alarm will be triggered automatically when the pressure reading exceeds our predefined safety threshold. Third, the system will provide accurate detection of that pressure threshold, meaning it will be distinguish between safe and unsafe pressure level. And fourth, we aim for stable and responsive performance, where the system reacts quickly without delay or false alarm. Beyond those four outcomes, the system should also demonstrate three key capabilities. An early warning capability. The buzzer provides operator with a rapid alert before pressure becomes dangerous. A basic industrial safety concept. This prototype simulates how real industry safety systems are designed to respond to abnormal conditions. And finally, a reliable Arduino-based monitoring system provides that a low-cost microcontroller can perform persistent and stable data acquisition. Assalamualaikum warahmatullahi wabarakatuh. My name is Ariff Zaqwan. Today I will present you about our project timeline, which spans a total of 14 weeks. We have divided the project into 4 phases. First, the for the phase 1 is about planning and proposal. We begin with phase 1 in week 1 and 2, where we conduct our problem analysis and define the scope of the project. From week 2 to 3, we carry out our literature review to support the technical background. Our proposal was submitted in week 4 and the proposal version was delivered in week 5. Phase 2 is about hardware and programming. Phase 2 covers the hand-on build. We begin the procurement of a component in week 6, keeping within our budget of under RM400. Week 7 is dedicated to circuit design and hardware setup, followed by Arduino programming and control logic across week 7 to 9. For phase 3, testing and analysis. In phase 3, we move into testing. System testing and troubleshooting take place from week 9 to 11, where we verify the accuracy of the pressure reading and the buzzer alarm. Experimental design and data collection runs from week 10 to 12 to gather result for analysis. So from the phase 4, the final submission. Finally, phase 4 brings us to the conclusion of the project. The final demonstration and presentation is scheduled for week 12 and 213, where we will present the work prototype. The final technical report will be submitted in week 14, completing the project. So, overall, a timeline is structured to ensure we have sufficient time for both building and testing the system before the final submission. That concludes our presentation. Thank you, and we welcome any question.